temperature rise. Thank you, Mark. And we are soon to be also, James Hansen says past 2 degrees. I've read several articles recently that say we are now committed to at least 2.5 degrees temperature rise. So things aren't particularly pretty. Where do we spend our time when we're working on climate? Fundamentally, I think it is focused on uh, GHG emissions. This chart has a map of a variety of the indicators that we've been using of CO2 and methane and nitrous oxide and so forth. Our whole focus is let's reduce GHG emissions, and I don't want to say that that's wrong, but I want to say it's far from complete. When we look at GHG emissions, probably the one of the best tools I have seen, hopefully you know it or will check into it, is Climate Trace. This is the most recent Climate Trace report. Climate Trace has measured more than 60 gigatons of CO2 equivalent emissions last year and this year. Emissions this year are actually 0.4% higher than last year. That's even considering all of the amazing solar and wind that we have deployed around the world. China was deploying a new gigawatt of solar every 18 hours, for much of this year. Just extraordinary. And yet emissions continue to rise. So, not to say that our effort on emissions is unimportant, it's vital. I recommend working with 4 particular tools when it comes to the current state of emissions. All of these are important. We just looked at some output from Climate Trace. They have identified 730 or so million high emitting sites around the planet. We should be knocking on the doors and trying to reduce those emissions. Project Drawdown is got many perfectly beautiful science-based climate solutions in mind. Nature Quant is says plant more, provide more nature, and we will increase the life expectancy on the planet. And in particular, En-ROADS. I want to focus on En-ROADS just for a moment. It's from Climate Interactive and MIT. They have just released a new major feature added to the En-ROADS model. And in this feature, you can name a place, San Diego County, and they will tell you what the expected temperature is or will be in 2100. And you can enter various policy actions, and see what set of policies would bring the temperature down to, less than 2 or preferably less than 1.5 degrees centigrade. One of the things that their new release really highlights, and I thought it was quite amazing, is that the temperature is rising much faster on land than over the oceans. It's sort of intuitive if you think about it, but it hasn't been described numerically before, this current tool, I believe. And they predict that if we do business as usual, the temperature in the Arctic will be somewhere between 10 and 11 degrees centigrade higher than it was in 1850. So we have much work to do. These are great tools. If we want to regenerate our planet, by all means, let's push the gas pedal on greenhouse gases and continue with that effort and improve it. We have uh, passed a place of stability on our planet. We actually are in overshoot. Um, Imagine in your personal bank account, you take out $1,000 every day and you put back 500 from your work or endeavors. Uh, it's not too hard to figure out that pretty soon you're going to be in big trouble. You're going to hit zero in your bank account, and then you will go into debt and then eventually bankruptcy. We are bankrupting our planet right now. this wonderfully interesting new book is going to be published in January. It's not out yet. On Natural Capital by Sir Partha Dasgupta from the UK. And he and others have been writing about this overshoot phenomenon, and the ideas from his book. If we uh, remove a ton of fish from the ocean and we allow the ocean to only replace a half a ton before we take out the next ton, that's the same phenomenon as our bank account. When we use water for irrigation, we're doing the same thing with respect to our water supply, our freshwater supply. And draining wetlands is a disaster for the planet ultimately. Although we use them to grow more food, we can't afford to just keep draining our wetlands. These are just examples of some of the overshoot. Uh, Bottom line, in July 25th of this year, we hit World Overshoot Day. And for the past 50 years, we have built a deficit of about 20 years. That is, we have 20 years. We need to stop taking anything from the planet and let it recover for 20 years, get back to the place where we were perhaps in 2050 or thereabouts. I don't know how we do that, but uh, given our population and so forth. But when you consider the state of world overshoot, uh, it's getting earlier. Last year, by the way, it was August 1st. Uh, I don't find our Sierra Club friends or anybody talking about overshoot and what our plan, what our policies should be to address this. And if we're going to regenerate our planet, we have to come to grips with the fact that we're using more of the planet's resources every day, every year than can be replenished, that are replenished. I mean, there's so many examples. We used to find copper ore with 20% copper. We're now down to 0.2% copper ore. It costs a lot more to refine it and get the copper and so forth. And so, whatever resource you're looking at on the planet, we're using too much of it too fast. And I would urge us to uh, start having a conversation and perhaps form a committee of some sort to begin thinking about this and begin setting some policies and arguing or urging others to pay attention. Not paying attention is not going to be successful in preserving our resources, to be sure. Having said all of that, the main focus of today is on what we're not paying attention to with respect to climate. And I want to recognize Viktor Gorshkov, who has passed in 2019, and his student and collaborator, Anastasia Makareva. We're going to see Anastasia in a movie clip briefly in a bit. Um, they together did the research from Russia, where they're faculty members, um, to discover the phenomenon of the biotic pump, which is part of what we want to talk about today. And they say, yeah, this is Anastasia, if the destruction of natural ecosystems continues, then reducing carbon dioxide will not stop the looming and environmental climate catastrophe. There's a second part to the climate crisis, which is the one that we're hardly paying attention to from what I can see, and that's what the most of our focus tonight is going to be on. Our key strategies will be to looking at approaches to regenerating forests, restoring degraded lands and watersheds and overused, if you will, resources, restoring our water cycles in particular. We have huge, huge stresses on freshwater cycles everywhere on the planet. Uh, Consider using regenerative agriculture. And in the latter part of the presentation, we're going to focus specifically on the San Diego region, our watershed, our coast, our county, because that's where we hang out. I propose that we also join large-scale efforts on the Amazon and restoring the Amazon rainforest, and I'll explain why, I think, in some detail. And we'll look also at ocean ecosystems and specifically, uh, we'll ask the question, can we develop a biotic pump, whatever that is, in San Diego County? So that's sort of a roadmap for the next part of the discussion. My thesis here is greenhouse gases heat the planet, but they're not the major driver of climate change. Instead, what is water movement and water state changes. And I hope to defend that, I think, bold statement and propose that the Amazon forest is, in some profound ways, the heart and lungs of our planet. The forest, these are flying rivers in the Amazon. This is a picture of a place in the Amazon, and you can see the flying river going through. And if you take a larger view or big perspective view, there are flying rivers throughout much of the Amazon, especially. Uh, how do they come about? Where did these flying rivers come from, and what role do they play in anything, and what do they mean? So, what is a biotic pump? Forests experience heat and transpire, creating particles in the atmosphere, creating clouds. Forests actually have more water vapor than the oceans, than the air over the oceans, I should say. Water vapor rises and forms clouds. The Gulf Stream, there's two kind of major air currents on the planet. The Gulf Stream is 5 to 10 kilometers above the forest. This is uh, where the clouds form in that altitude approximately in that general area. And when the clouds are formed, they create a drop in the air pressure lower to the ground. That drop in the air pressure, the lower air pressure, sucks in moisture from the higher air pressure. And if the forest is by the ocean, it's drawing in moist air from the ocean itself. And that moist air replenishes the water in the forest. It the movement from high to low pressure sucks in the air and is fundamental to creating the water vapor that turns into clouds that, in effect, produce rain and also reflect heat off of the planet. So the process of forests bringing in water is referred to as the biotic pump. This is the work of Goshkoff and Makareva. They call it the biotic pump. By drawing water off of the moisture over the oceans, they're bringing more water into the rainforests so that they can indeed be called rainforests. The action of the biotic pump is fundamental to how natural systems stabilize themselves, how the forest actually sustains itself. The temperature difference between a vegetated transpiring surface and a roadway can be 20 degrees C. I mean, it can be absolutely massive. So we know if you're standing in the sun and you're hot, step under a tree and you instantly experience cooler. And the forest is just this in spades. So as water vapor condenses into liquid, we get a volume reduction. This is the biotic pump action happening. 22,000 cubic centimeters of moisture condensed to 18 cubic centimeters for each gram molecule of water. And imagine an instantaneous compression of 22,000 cubic centimeters to 18. That's the pumping action, and that also is the mechanism for cooling the planet in some profound ways. And we're going to look into that more now. Its implosive reduction causes the surface air to move upwards, uh, ultimately drawing humid surface air uh, from the same latitude ocean. We're now going to move it upwards with the pumping action. And that combined with recycling of evapotranspired water we're now irrigating the forest, the land far inland through the forest. And this is really important. This is fundamental stuff. Part two of the biotic pump. When we release the latent heat from using evaporation and it's water vapor, and the water vapor condenses into clouds, and all this motion, all of this transformation in water state releases energy equivalent to sometimes as much as 14 atomic bombs per second. The most important number on this slide is the Amazon is estimated to release the energy of approximately 300,000 bomb equivalent energy bursts per year. That 300,000, this function of compressing the flying forests into clouds and drawing more water off the ocean is fundamentally the cooling function and the driver of protecting our planet from excessive heat. In fact, when the Amazon was fully intact, and still sometimes 70% of the heat that arrives from the sun is exported back into space through this function, as well as, of course, the albedo, the reflectivity of the clouds, and so forth. But this whole complex of activities are the most important cooling mechanism on the planet, as much as several hundred times greater than cooling from planting trees and using biomass as a carbon sink. So I hope it's clear already. By the way, Peter Bunyard is a British scientist, and he and his partner Rob DeLayet wrote "Cooling the Climate," and Peter defined a series of experiments to document and demonstrate that the biotic pump mechanism is real and that it works the way Anastasia has explained it. And this is some of the information from their research. If the Amazon turns into a savanna, the heat that doesn't get returned to space through the transpiration and cloud formation could make the planet literally unlivable. It will get too hot. We could exceed the wet bulb temperature. And I put this slide in just to make the point that if you look across from Mexico and Western Amazon and across the Middle East and India and so forth, much of this land, and some of it, it's not to scale here, unfortunately, some of it also in Africa below the Sahara, much of this will exceed or could exceed the wet bulb temperature. In other words, it would be unsurvivable for humans. This is a clear risk for the path that we're on. We can make large fractions of the planet unsurvivable. Forests don't then just use water. Of course they do, but they help bring water to the land through the pumping mechanism. The fundamental physics here is when water vapor condenses and so forth, the atmosphere loses mass. This is just repeating in a different language. The biotic pump describes how moisture recycling happens, what the dynamics are, the atmospheric dynamics. And some dry regimes exist where additional plant moisture does not trigger extra local rainfall. This is not the pump. In other words, there are conditions in the forest to create the biotic pump. I'm going to talk about them, and especially when we get to San Diego in the discussion. You can't just plant trees and think you've done it. It's not. Pumps don't just happen because we plant trees. We need to figure out how to enhance with extra moisture import from the oceans or from nearby water bodies. Large lakes can perform the same function of providing moisture in the atmosphere, but we can't just plant tr tree plantations and expect that this is all going to recover our hydrological cycle. So it's important that we understand the biotic pump mechanism, but also what are the minimum criteria for a forest that will pump, if you will. What are we doing to our forests? Well, 12,000
Cutting them
years,
down.
what's that? Anyway, 12,000 years ago, uh, on the planet at the beginning of the Holocene, we had roughly 6 trillion trees. Today we have 3 trillion. So, we pumping mechanisms that were fully active in the past are not necessarily so much now. This is a palm plantation in Borneo. As you can see, we cut it down and then we plant palm trees in rows, and that's not going to create a pump of the sort we need. This is a sawmill in Africa. By the way, I think I've got it in a slide coming up. African forests are now net emitters of GHGs, not sinks. They're a source, not a sink. This is all African forests collectively right now. We've cut down too much. It's just absolutely tragic. This is another phenomenon in Brazil that isn't very well known in some ways. What happens here is Brazil. A lot of people have burned the forest to plant palm, soy fields and to support cattle feeding and so forth. And a lot of the Brazilian economy is based on that now. But people have been arrested for burning the forests. So instead of burning it, now we've got people poisoning it with chemicals, killing the trees. You can see the dead trees all over this picture. And once they're dead, you can cut them down. There's no problem, and you don't get arrested for burning the forest. But bottom line is, you still have destroyed the forest. Not pretty. So as we cut down forests, we reduce evapotranspiration, we reduce clouds, we reduce the cooling, in other words, increase the warming. I would ask, what would happen if we cut trees and instead of having 300,000 explosions of heat off the planet in a year, we went to 250? Well, clearly, or some lower number, clearly heat will stay on the ground. And what are the impacts? Well, number one, we know with more heat, the vegetation will retreat. Biodiversity, which is rampant, or the forest, the rainforests in particular, have more biodiversity than any other place on the planet. Biodiversity decreases. And so what we would ask is what happens to lakes and rivers as the forest begins to heat? Uh, Here's part of the answer. Here's a large lake, what used to be a large lake in the Amazon. It's Lake Kofe. Uh, its normal or typical temperature has been about 90 degrees or 85 degrees. It's now running at 104 degrees Fahrenheit. Uh, the energy required to shrink this lake by 75% in area is massive. In the process of the heating, it killed fish and frogs and all kinds of other life. And many Amazon forest lakes are drying up and dying, as this one is. It's just an effect of cutting down the forest. And I also asked what happens to the Amazon River. This, please believe it or not, is a picture of the Amazon River in 2023. It's like people walking across the river. Uh, Now, it's also true, you probably know that much of South America's energy comes from dams. If you have less water flow, what happens to the energy, through running through the dam or coming from the dam and the turbines associated with it? Well, obviously, you have less energy availability. So this is the consequences of the Amazon being, a more or less dry field instead of a river are just extraordinary. The drought in 23 and 4 was caused by the loss of cloud cover. Bolsonaro and his supporters, as we know, cut down trees, and he gets to enjoy jail for the next 27 years or something for his malfeasance. And coming from Washington, we now have a proposed Fix Our Forests Act. You know, we've all heard of Orwell, I know. This is Orwellian. The Fix Our Forest Act says cut down our trees and remove the detritus from under the trees and the lower shrubs, and the forests won't burn. Well, number one, that's wrong. And number two, it's just we're just headed again in exactly the wrong direction. Indonesia is doing massive deforestation. Uh, Forests with maximum primary productivity. I want to talk about this point because it's a little techy, but it's kind of important. The primary productivity that comes from a forest is the amount of greenery that grows, the calories and whatever that grows. And the major forests on the planet are listed here. We all know where they are, to be sure. But what happens is in the Amazon, when it was in its more pristine state, if you will, the net primary productivity was consumed 1% by vertebrates. That's us, humans, jaguars, whatever. 10% by invertebrates, and 90% by bacteria and fungi. Kind of amazing distribution of using the energy and the greenery and growth in the forests. Today, however, humans are consuming 30% of net primary productivity from the Amazon. Now, one of the planetary boundaries talks about net primary productivity and says that the limit for human consumption for net primary productivity on the planet should be 10%. Beyond that, we've exceeded. We as humans are taking too much of the productivity of plant life, if you will, on the planet, and not leaving enough for other life forms. So the Amazon is all by itself, as well as the rest of the planet. We are far beyond, consuming far beyond the sustainable capacity. Goes back to our discussion of overshoot. As we clear cut forests, droughts become more extreme, deserts expand, and most deserts have been created or spread by cutting our forests. A key cause of global desertification is underway today in most of our forests. And I want to just digress for a moment from our slides. I want to play a brief movie clip. Um, oh, okay, sorry, I did the wrong thing. This is from a movie called Old Growth Forests, done by the New England Forest. It's produced by New England Forest. And this first clip, I'm going to show several clips tonight, if that's okay. The first clip is actually from Anastasia Makareva. We'll see her for the first time.
We can actually understand much better several enigmas in human history, like, for example, the fact that Australia had once very rich vegetation became such a big desert. This happened approximately at the same time when the first human settlers came to the continent. And if they were making fires in the coastal areas where they were settling at the very beginning, they could just cut the pump of the inner forest from the ocean, like making area without vegetation that could disrupt the moisture flow, and then the inner forest would dry out very, very quickly because the fresh water amount on land is very small on geological timescale, and it could evaporate or run down to the sea in just a few years. So in that case, we would have seen a desertification of the entire continent nearly instantaneously. There is a natural fire dynamics in a forest, which is like relatively infrequent fires, but then you add logging and the tree stands become even aged and young, and they have much higher flammability. And at a certain point, the threshold is passed, and the ecosystem is put on the self degradation trajectory and never recovers. So there's no recovery at all. And they call this landscape trap. So the landscape is trapped into a drier, depauperate state.
Oops, sorry.
Here in the northern hemisphere, we have this temperate and boreal forest belt in Canada and the US, and then in Russia, which spread.
Sorry, I didn't mean to continue there. I just fussing with the technology a bit. Let's go back to the slides for just a moment. As you could see from that quote, from what Anastasia was saying there, 50,000 years ago, when humans arrived in Australia, it was forested everywhere. Today, it's desert virtually everywhere. If you've been there, you know, I've seen it. When the coastal forests were cut down by the arrival of humans, 50,000 or so years ago, uh, after that happened and the pumps failed, it took about 10 years. Anastasia writes some of her writing, not wasn't on this film clip, but she said approximately 10 years, the entire continent became desert, in effect. And one of the ways we know that is that there are fossils of tree kangaroos found everywhere through the Australian desert. They don't live if they're not in trees and so forth. So we get the point immediately that, you know, if in a few decades or decade or whatever we can destroy the Australian forests, cutting down our trees is not a very desirable thing to do. I'd like to turn to now to another, just for a moment, a second video clip.
Oh,
Sorry. I'm going to go to 45. Another person, by the way, we're going to see on the films is a fellow named Milan Milan, who has also recently passed, but he studied local and regional water cycles, especially in the Mediterranean. And so we'll see some of his amazing insights also.
For a city of 8 million people. The water table used to be about 8 meters down. It's now almost 80 meters down. Forests influence precipitation downwind for hundreds of miles farther inland, in effect becoming a pump that delivers water across a continent. But, according to Milan, as soon as we alter the land cover, even in a small area, by reducing vegetation or negatively affecting the biota of the soil community or developing and paving, we immediately affect the precipitation downwind. And that is regardless of whether we affect one larger area or a collection of small ones. It all adds up. Greenhouse gases spread around the globe and tend to affect Earth uniformly and gradually over a period of time. But they are only half of the climate story. Altering land cover has an immediate effect on the local temperature and water cycle. Further changes to land cover eventually brings us to the point where the local water cycle is destroyed, regional cycles are affected, and only larger scale precipitation occurs. This is the other half of the climate story. It was known about more than 50 years ago, but has been largely ignored since CO2 became the focus of attention. So, is climate change real? Is it caused by man's activities? If you've ever driven away from a city to a forested area on a hot summer day, you've no doubt noticed that it's much cooler in the forest.
So here we have the movie folks basically telling the story or reinforcing the story that we've been talking about till now. Uh, Come on, where's my slides? Uh, I just thought I'd point to a couple of other things. I mentioned it in the preceding slide, I think. Let me go back. I think it's important or interesting. The major forests on the planet, the Middle East, Gobi, our here, the US Southwest, Australia, all of these and more have become desertified because of, in part, our cutting of trees. This this I saw in the news today, and it just tears my heart, I tell you. The Tigris Euphrates was the birthplace, the cradle of civilization, as we call it. The Tigris is in danger of disappearing. Literally, this is a picture of the Tigris River and some fishing boats. Right now, Iran has major water stresses in their around the country because of they've cut down their forests. Sao Paulo, the largest city in Brazil, today has 1.3 million. This is all this month, by the way. 1.3 million utility clients without power due to drought. Literally, they don't have water. They don't have water to drink, and they don't have water to generate the electricity, uh, through their dams. Africa's forests, I said that a bit ago, now emit carbon rather than store it due to deforestation, mining, and so forth. COP30, it finished recently, the UN annual climate meeting. Brazil proposed a tropical forest forever fund and said we need $25 billion to protect and restore the tropical forests on the planet. They have commitments for 6.6 billion, and they need probably more than 25 billion, but at least that. So, we're on the planet scale, we're not paying attention. And I wanted to share this highlight too, because it begins to get to our Southwest problem here. New Mexico has lost there's a 300-mile arc of ponderosa pines from New Mexico
200 miles.
To the Sierras, and we have lost since 2000 200 million ponderosa pines. And there's an expectation that in the next few decades we could lose more than 90% of all the ponderosa pines that we have, again caused by drought and wildfire suppression in this case. And the forests, of course, shift to grass and shrublands, which aren't particularly helpful for the water cycle. I'd like to deepen now our conversation about Brazil specifically and say more about the Amazon. And I promise I'll later connect this to San Diego, amazingly enough. This brown area, this is from the World Wildlife Federation. The red areas here are human cut downs, the destruction of the Amazon. And you can see there a great deal from the Atlantic all along the southern part, up here in Venezuela and in the the western Amazon, and down here in Peru and Bolivia. These are all scattered all over the place. What happens is the pumping action starts at the Atlantic. The top part here in blue is specifically during the wet season in the Amazon. And the water is pumped in and becomes clouds and rains. And then it's used by vegetation and it transpires again and rains and so forth. And so one drop of water coming from the Atlantic will actually, by the time it gets to the western Amazon, will have been in clouds 5 to 7 times and rained out. Now, in yellow here are sections of the Amazon that are turning to savanna because there's not enough water. And as the pump fails here, in particular in the north, when the winds and the rain get to the Andes, they turn south. And so Peru and Bolivia, this is probably the next major section that will become just savanna of the Amazon, from the cutting down of the forest in other places in Brazil. As I said, the moist air comes in, condenses, transpires, and usually 5 to 7 cycles, we end up in Peru or Bolivia. The Amazon's tipping point is the time when we transition from forest to savanna. The flying rivers move east to west, as we just saw. They cycle a few times, 7 times perhaps, before they then move further south across Argentina and the like. This is the primary source of water for all of the Western Amazon, or most of it, in much of South America, and also, by the way, we'll see here in San Diego, interestingly. Uh, the deforestation disrupts moisture flows. Forest must be regenerated with that $25 billion fund, in part, uh, to protect the hydrological cycle. And what Brazil is doing is continuing to build Brazil Route 319 right through the most untouched portion of the Amazon. Well, building the road's going to destroy the forest, and then along the road will be access to cutting down more of it to do whatever, agriculture and mining and so forth. Brazil's also planning a 600-mile railway. One of the things that I ran across recently, Mark told me he saw the same article. Um, a key goal for China is to have access to to Brazil's timber, soy, beef, and all that stuff. And in Peru, China has built the port of Chancay. It is the first outside of China fully automated port in the world. There are four in China itself, and this is the fifth in the world. And what happens is six workers sitting in front of screens manage all of the loading and unloading of 54 docking bays. It's just amazing. And this is the first phase of a three-phase massive port. As it's constructed, it will destroy much of the Amazon and result in that. It also shortens the shipping routes from Western Australia, from Peru to China, saves them time, gets them products that they want. And look at what Brazil's doing, building highways, waterways, airports, ports, railways, all to support this port in Peru. Over the last decade, 4 million hectares of forest have been lost for China's imports, and 70% of it's been cut illegally. It's just a tragedy in the making. This will likely turn the Amazon into a massive emitter of GHGs. Money, money, money. Projected Amazon forest cover loss. Amazon today is estimated to have lost 13%. That's 5.5 million square kilometers over the last 40 years. equivalent to the size of Spain. This, by the way, the Amazon stores 10% of all carbon in terrestrial ecosystems on the planet. The tipping point is estimated to be between 20 and 25% loss. And expectations are from a report released on 12/15. This is, by the way, the back of the slides, if you get them later, have all the references to this information. But this report from the university in Zurich says that by 2100, they expect the Amazon to lose 38% of its cover. And their research says if the temperature hits 2.3 degrees centigrade increase, the speed of loss of the forest will increase. So I hope it's real clear by now. We better protect the Amazon, right? These flying rivers, by the way, we said happen in the Amazon, of course, but they also happen everywhere. We have found from the forests in the Pacific Northwest in Washington State, we have found the rainfall on the U.S. East Coast that started in the Pacific Northwest. And, isotopic water has been used to document that. Interestingly enough, the forests in Scandinavia and Russia, this is where Anastasia Makareva does her research, move water into China, and they are responsible for about 80% of the rain in China. Uh, and China has a contract now with Russia to pay them to cut down this forest so that they could get forest products to China. And, they're just shooting themselves in the foot. It's just nuts. And of course, there are flying rivers in Africa and Indonesia and so forth. So this is a pervasive where we have forest phenomenon. The tree canopy cools everything. Moisture rises from soil and roots via the leaves. Dead logs, this is Anastasia's work here, should be left in the forest because they hold moisture and they provide homes for all the beasties that absorb the dead wood and fungus and so forth. This is more important than the fuel load. And, our president told Governor Newsom that we should rake our forests, and that's exactly wrong, according to the research here. Managed forests with no dead logs burn more, not less. Open forests burn more. They reduce moisture. And I'd like us to take one more, our third of movie clip, 33.
Not only is the forest shady, but it cools itself by transpiring water, much were cut. It's critical that there is adequate, vibrant, mature forest cover to constantly maintain the soil sponge and the local water cycle. When forest cover is reduced or removed, the local feedback loop is compromised or eliminated. Rainfall diminishes and the land becomes drier. Vegetation dries out. Stream flow declines and water bodies dry up. There's only one way to prevent or reverse that slide toward desert conditions. and that is to have adequate, natural, mature forest cover to maintain the water cycle. There simply is no other way to keep the soil sponge intact and the land hydrated. Young, early successional forest is not as effective at this job as very old forest is. Likewise, neither are tree plantations. Younger, smaller trees typically don't have the robust ground structure of older, larger trees, nor the capacity to transpire the right amount of moisture at the right time. Old trees are well adapted and have already survived a wide range of environmental conditions. They have well-developed, deep root systems that can access a deeper underground water table during drier times, keeping transpiration rates high and the feedback loop working. Young trees have not yet developed deep root systems, so they cannot access a deep water table when needed. Furthermore, old, unmanaged forest has a deeper organic duff layer with greater amount and diversity of organisms that constitute the soil sponge. Old, natural forests are the pinnacle of what nature has evolved to make Earth the livable planet that it is.
With this biotic pump concept in mind, we can actually
What strikes me especially about that movie clip is the statement that, well, here we go, that the only way to preserve local and regional water cycles is through forests,
Old growth.
old growth forests in particular. Absolutely. So the to summarize, benefits of forests, they reduce air pollution, they put they absorb and collect particulate matter on their leaves and barks and so forth. They lower temperatures and uh, cool the planet and reduce the excess heat on the planet. Uh, they have they provide physical and biological filtration of the soil through their roots, through the fungi that metabolize synthetic compounds that are associated with the forest floor. Canopies and leaf litter intercept micropollutants. The forest buffers the environment from some harmful novel entities. With that summary, I'd like to just pick up a couple of ideas from the planetary boundaries work. This is a chart from the planetary boundaries report a couple of months ago, the most recent, in which they talk about two things impacting climate change in particular and the heating of the planet. One is exceeding 300 parts per million of CO2 and so forth in the atmosphere. Uh, right now, they say the 2025 value is 423. We hit 430 earlier this year, and this morning it was 427. When we hit 450, we'll be at the high risk zone. But there's a second measure of heating, and that is called here radiative forcing. It's basically how much heat does the planet retain after it arrives from the sun, how much of it gets retained. And the maximum safe limit is said to be 1 watt per square meter. and high risk at 1.5 watts per meter square. The current value in this year is 2.97. So the planet is holding in far, far too much heat in this measure. The planet with the forest, with the extra warming is, and this is from an organization associated with Lancet, the planetary health health folks. They say that, again, we've got in their mind 1.89 watts per meter square in excess. So regenerating the Amazon and the other forests of the planet on the planet appear to be the only way to cool the planet effectively and rapidly. So we could probably cool the planet within decades if we made an all-out effort to regenerate our forests and to expand our forests. This is a profound conclusion to me. Um, One more thing that forests do is release bioaerosols that are the cloud condensation nuclei. And one of the important things that's happening to us right now is as we increase CO2 in the atmosphere retains more water vapor. A 1 degree centigrade increase in temperature causes the atmosphere to retain 7% more moisture. That eventually oversaturates and we have a huge dumping going on. And this is the creation of atmospheric rivers. This is where they're coming from. They can be truly extreme. In 24 hours in Vietnam in last month, we had a 60-inch rainfall. You'd imagine 60 inches, 5 feet of rain in 1 month. I mean, we wiped out part of southeast San Diego a couple of years ago with a whole lot less than 60 inches, probably closer to 10 or something. This is phenomenal. But consider the ocean as the atmosphere holds all this ocean, all this additional atmosphere, it's moisture rather, it's sucking it out from the land. 70% of the planet is ocean, and more of the atmospheric rivers dump over the ocean, which has the net effect of drying out land and desertifying land everywhere. This is in the process of happening now. So when we talk, going to have a couple of slides about oceans in a moment, but phytoplankton and foliage are fundamental to the rainforests raining, if you will, and the oceans creating clouds also. So forests cool the planet through transpiration, through shading, through uh, water vapor, through cloud formation, through transporting latent heat to create the pumping mechanism and creating the clouds, and through reforestation, we decrease the warming effects of GHGs. So, as we said before, focusing solely on CO2 misses the big picture. Water vapor is actually 96% of the GHGs on the planet. Most of the planet, 70%, is oceans. And the oceans are a further critical determinant of water vapor, clouds, and this whole process. Right now, we have a substantial loss of phytoplankton, and there are methods to increase phytoplankton if we choose to take them on. But phytoplankton are also absolutely critical to cooling the planet. One of the things they do is by existing, they eat CO2, if you will. When they die, the CO2, they fall to the ocean floor and are sequestered for, many thousands, maybe hundreds of thousands of years. So if we lose phytoplankton, we have lost that carbon sink. Also, phytoplankton emit aerosol particles that help in cloud formation. And they also produce half of the oxygen on the planet. So if we don't have enough phytoplankton, we will have struggle with perhaps breathing. So warmer oceans hold less CO2, which means that outgassing could lead to increased CO2 in the atmosphere. So all of this ties back to what we were just talking about. Ocean layers. There are three basic ocean layers. The top layer, the top 100 meters, called the mixed layer, absorbs sunlight, temperature is rising there. It is wind, waves, and all kinds of chemicals, plastics and phytoplankton and other particles there. Uh, that layer is getting polluted with plastics, etc. There's a boundary. It's typically been about 1,000 meters called the thermocline. And below that, the temperature of the ocean drops dramatically and quickly. It's been about 1,000 meters. It's now 2,000 meters in many places, including here. Neil Driscoll is a professor at UCSD who's a friend and who founded and manages the Alert California Fire alert system at UCSD. And I was talking with him, and he's also an oceanographer, and he was just mind boggled that the temperature is 2,000 meters now before we hit the thermocline. In the deep water, very cold water, moving water from pole to the equator, this is the most dense and the most saline. And interestingly, this is where the AMOC, the Atlantic overturning circulation, is at risk of slowing down and stopping uh, in the next decades. So the oceans are at extreme stress. The top ocean layer is experiencing phytoplankton decline, as I said. You know, it's a 40% decline since 1950 due to particles and plastics and chemicals and the like. This is the foundation of the ocean's ecosystems, the food systems, the phytoplankton. It also, as I said, produces half the Earth's oxygen. It's kind of important. The ocean absorbs less CO2, which means temperature increases. Billions of people depend on the ocean for food. And we have stresses there. And I don't know if I said it here, but the forests create bioaerosols that float over the ocean also and contribute to the cloud formation, which is so vital to cooling the planet. I wanted to just highlight one more of the uh, planetary boundaries, and this is biogeochemical flows. The bottom line is we use nitrogen and phosphorus as uh, fertilizers, and we're using far too much. Our safe level of teragrams per year of uh, phosphorus is 6. We're at 18. Similarly, 62 teragrams for nitrogen, and we're at 165. So we are polluting the oceans with our agriculture, and some of the effects look like this. This is the Florida coast. It's supposed to be ocean, but what it is an algal bloom. In fact, it can look like this. The Sargassum Sea and the plastic in the Caribbean, this stuff, this algal bloom here, runs for 5,500 miles in the Atlantic in the summertime. It kills animals, harms human health, discourages tourism. This is a picture of Miami, by the way. This is from Miami, and we're creating all this mess in our oceans, and from our agricultural practices and not managing the fertilizers that we use in a sensible way, in an optimum way. So reviving ocean ecosystems is also, of course, crucial everywhere. In 1940, ocean pH was 8.2. It's now expected by the next decade or so to be 7.95. So the ocean is acidifying, and the most recent planetary boundary to be exceeded was the ocean becoming too acidic. And uh, as it becomes too acidic, it not only interfaces with the phytoplankton, but it also means that all the shelled beings, corals and and oysters and clams and so forth can't produce their shells because they don't have enough calcium carbonate and the like. So we're approaching the ocean acidification tipping point. The result of that, if we reach it, will be the death of ocean life could be unstoppable. So this is pretty serious stuff. When we're going to regenerate the planet, we really have to pay attention to our oceans and our agriculture as suggested here. Action plan, stop poisoning the ocean life, stop using toxic chemicals, stop seafloor, seabed mining. Uh, Trawling the ocean floor needs to stop. We need to stop overfishing. We need to build massive marine protected areas. There was some improvement in that in the last UN meetings about this. We now have some marine protected areas that are out in the middle of the ocean beyond the 300-mile limit that countries claim off their coast. And that's good news. And restore coastal marine ecosystems, including large-scale plankton restoration is needed. And we should be thinking about what we're going to do in San Diego County with our fantastic coast in this space. Now, we're going to now shift, having said that, to a discussion of San Diego. And as we do, I want to finish this discussion with a quote from Antonio Nobre. He is a recently retired um, uh, leading scientist in Brazil, focusing on the biotic pump and the implications for his country and the planet. And this was a quote the statement that he made to COP30 a couple of weeks ago. Here's the uncomfortable truth. Even if we zeroed out carbon emissions, worth doing, without massive ecological restoration, the climate emergency would persist. By damaging the ocean, atmosphere, land, water cycle, we drastically impact climate sensitivity to CO2. Forests aren't just carbon sinks, they are the planet's regulator of fresh water, the generator of fresh water, and the foundation of habitability. So he summarizes there or argues in this statement exactly what I hope I've been talking about for the last bit. So, last video quote I would like to offer is go back to the movie. We're going to now turn to San Diego. This is now Milan in this segment talking.
Some other place. Where does the additional water vapor come from? From the source that nature has provided, the forest. So Milan found that sea breezes carried water vapor on shore and, historically, the forest had transpired enough additional water vapor each summer day to allow condensation and clouds to form. Then an afternoon storm would drop water back on the forest. It was a local feedback loop over the forest that recycled the same water over and over all summer. It's known as the small or local water cycle, in which about half of the rain that falls on land is this locally recycled water. Farther inland, the percentage is even higher because with a contiguous forest cover, wind carries the transpiration precipitation water cycle across the land. Coastal deforestation had interrupted the forest belt and eliminated the local water cycle in the Western Mediterranean.
You change the surface of the land use cover and you immediately change that cycle. Land cover is the driver of the second leg of climate change. Everywhere that you change the land use around any coast, the part of the water cycle that was driven by the sea breezes on that coast changing. This was first presented in San Diego, California in 1997. And the head of the U.S. Forest Service at the time said, if what you say applies in California, we will have serious problems with forest fires in about 25 years. That was said in 1997. In California, you have lost the local precipitation in the summer afternoons. The ground has dried up. People have built in the forest. Now the ground is much drier than it used to be before, and it becomes a fire trap. When you have forests and soils, you had a huge amount of water trapped in the soils and the forests. As we have changed land use, all the water that was in the soils, in the forest, is now somewhere else.
I was quite stunned to find this segment about San Diego in this movie, but it certainly is relevant to what we want to talk about. What about our local water cycle, and what does this mean for us? I would like to introduce or mention a report published last week by the Colorado River Research Group, and it's called Dancing with Deadpool. In case you don't know, Deadpool happens when lakes, Mead and Powell and so forth, have not enough water to fill the pipes that drive the turbines, and we can no longer create energy. So that's an energy dead pool. And below that, at lake level, is a point where the lakes don't provide any water to the river, and that's just total dead pool. We have no more water from the in our case, the Colorado River. Now, San Diego receives roughly 60% of its water from the Colorado River. This report says precipitation in the river has declined 7% this century due to human activity. Well, I'm going to say that that's in some significant part due to deforestation. And they argue, this is quotes from the report, they won't rebound until we do something about it. And the climate-water connection is of global importance. These are statements from the report. By the way, the title of the report is Dancing with Deadpool. It's absolutely devastating about water in the Colorado River. We have so many issues there. We don't have time to get into those tonight. I know Stefan did a wonderful job in his presentation last month about this, but it is just absolutely vital that we pay attention to our Colorado River. For watersheds that get trapped in perpetual dryness, what we need to do is protect and restore the natural ecosystems. We've already seen in the movie clip, forests are uniquely capable of sustaining the regulation of water cycles. And the key concept here is uniquely capable. We don't know any other way to sustain the water cycles in the way that forests do. So the key policy message is hydrological cycle has a strong ecological dimension, and protecting forests is equivalent to enhancing water security. And we are at risk there in big time. This is a report, a science journal article from 2013 about San Diego's river, water condition in the Amazon. This research has said if the Amazon hits the tipping point, LA will lose its rainmaking ability, and its water. The atmospheric rivers over the Amazon influence water levels in California. An Amazon stripped bare could mean a 50% reduction in the Sierra Nevada snowpack, which means no water, not enough water for the Colorado River, which means San Diego will be dying of thirst. If you change the snowpack, in the Sierra Nevada, where water comes for agriculture and so forth, there's also serious consequences, of course, for our food supply. So all this stuff we've been talking about the Amazon actually has a direct connection to to our water here and our Colorado River. As an aside, there was a report about a month ago that said that rain in the Amazon forest impacts the snow in Tibet. So, the air currents flow over the planet, and this is all this stuff is interconnected in profound ways. An interesting additional report that I wanted to highlight before we talk specifically about San Diego is the historical impact of climate in the eastern U.S. The eastern U.S. actually has a hole where the temperature is lower than around it. This is more in the southeastern U.S., the mid-Atlantic states, and so forth. Before European settlement, forests covered most of the eastern U.S., but then we cut down 90% of it for uh, urbanization and for agriculture and the like. And by 1930, we'd come to a place of realizing that we weren't using those agricultural fields; they were abandoned, and people started reforesting. And for the past century, we've been reforesting parts of the southeast. Millions of hectares have been added, and the warming hole in the eastern U.S. shows that the minor cooling trends of, up to zero point 0.8 degrees per 50 years can happen with forests. And they weren't trying to build a biotic pump, they were just reforesting. Uh, so the reforestation has led to a 1 to 2 degree cooling annually where we had grasslands and croplands in the past. Temperature reductions can be as high as 2 to 5 degrees centigrade from this reforestation. They make the observation that young forests have a significant impact in their research. Areas of reforestation are up to 1 degree cooler than neighboring locations that don't have the forests. And the study highlights that reforestation as a potential local climate adaptation strategy in temperate regions is available, which is this is an amazing piece of research, again, tying to what's possible if we pay attention. So, having done all of the work to the research to get to this point in the presentation, I asked AI, what can we do? What's possible in San Diego? Can we build a forest that has the attributes of a biotic pump? And I want to highlight now what basically the AI tool indicated. First thing is we've got to pick the right location. We need, ideally, locations that have degraded ecosystems. Definitely best to use native trees and native vegetation. The reforest areas with native trees, oaks. One of our friends, Jim Crouch, who might be on the call tonight, gives away oaks, and he's planning to give away 10,000 next year. So if anybody here or anybody is interested in oaks, we'll be happy to connect you with Jim. We could also build, as we're building a forest here, or rebuilding one, build a food forest, a medicine forest, or combinations. We could use agroforestry where we grow things under the forest and so forth. We also should restore are wetlands. Certainly the Tijuana River estuary, San Elijo Lagoon, and all that could be key focal points. One idea I've had is why don't we ask every schoolyard, or as many as practical, to install a pond? We have a associate who has been involved in pond building. We need to restore our wetlands. And if we put ponds in schoolyards, not only will they help with biodiversity and water, but they also could be fabulous places for class exercises, student learning exercises. We could integrate agroforestry in urban greening. And why not? San Diego could put in place urban forests with green roofs and street trees. Nature Quant, if you recall from back near the beginning, if we increase the nature score by 15 on a scale of 100, life expectancy increases by a year, but it also would play a key role in increasing humidity and cooling our planet. And this could be done anywhere, Escondido, El Cajon, the coast. Again, I would recommend a pocket forest in as many schoolyards as possible. And lots of cities have pieces of land that have been, I don't know, trisected by roadways or whatever. It's a little piece of otherwise useless land. We should put, mini forests on those pieces of land everywhere that we reasonably can. There are some available or some ongoing projects. The San Diego River Restoration and the Tijuana River Valley Restoration projects are already underway. Let's add to them, would be the argument. So selecting the right location. See, we already said this, didn't we? Yeah, sorry, I went the wrong way. Water management strategies. We should have a rainwater harvesting barrel in every yard and reuse it for hydration and farming of grain or gardens throughout the year. We should recycle gray water. This is an interesting thing. 30% of the homes in Australia have a dual plumbing system. The second plumbing system is the reuse of gray water, shower water, for example, to flush the toilets or maybe for gardening and the like. I would guess that there's something approaching 0% of the homes in California that have a dual plumbing system. There's a huge opportunity here. Soil moisture management could also help, and we should be looking at techniques to add moisture to our soil. We should collaborate with local agencies and communities. I mean, governments all have CAP plans, climate action plans, and gardening groups. School districts do. Environmental NGOs like the Sierra Club, community groups. All of us can contribute to working up a plan to build a forest large enough for the biotic pump. The San Diego County Water Authority and the Audubon Society and so forth. Guess what I'm saying is let's decide to build a forest that will accommodate and create a pump. I'll describe what it needs in a moment. And let's include as many people as we can and educate as many people as will listen. As we start doing more of the regeneration, we clearly need to monitor. This is a wonderful place to bring in, our universities to do research and to help us track progress and identify places where things aren't going as well as we'd like and to make appropriate adjustments. In other words, this is a community effort that I'm proposing, involving multiple organizations. It's not trivial. We need public awareness and education. This story that we've been telling needs to get out. We need to raise awareness of what we're trying to do and what it looks like. We need educational programs, get public buy-in. Uh, the United Nations Association group that I am part of is using virtual reality and related tools to build, or we're planning to do this, to build a climate dashboard and make it an immersive experience so people really get what's happening. We could include that, use those techniques here also. My friend Jeff is on the call here tonight and on this session, and he's involved in that project also. Long-term climate resilience benefits. We want to reduce heat. We want to improve water security, a big issue for us. Grow and support biodiversity, a big issue. Um, I got a call just an hour before we started tonight about uh, encouraging beavers in San Diego County and to create natural waterways and maybe removing some of our dams. All that could tie in beautifully to this initiative that I would propose we take on, and to mitigate climate change, of course, by sequestering carbon in all of the growth that we have. So the question becomes, what does it look like in San Diego, and where could we put it? Where could we build such a forest? There are three, I asked AI and they came up with three top locations. First, let's define what's needed. We need an area at least 10 square miles, as large as the Amazon if possible, but at least 10 square miles. And it should have 100% tree canopy, which means if you looked at it from top down, from above, from the air, you would see no ground. You'd see only green. And by the way, a tree that has a 1 meter diameter base, looked at from above, it has about 140 or so meters of ground cover from all of its branches and leaves. So uh, the old growth forests in particular can create massive cover. And the three recommended places, or three places to start looking at least as candidates to build a biotic pump forest, is the San Luis Rey watershed, the San Diego River watershed, and the Carlsbad. And here is a picture of, this is the 11, these are the 11 watersheds in San Diego County. The San Luis Rey starts in Oceanside and runs through the San Luis Rey River up to Fallbrook and over to Highway 15 and beyond. A great choice. The San Juan watershed, which runs into Santa Margarita and the southern part of Camp Pendleton, would be a second good choice. A third one would be the San Diego River, which starts in the Cuyamacas and is in the San Diego watershed, and possibly also in the Tijuana River Valley on the border. So we have multiple locations or candidate locations to explore. The San Diego River Gorge looks like this. It's quite clear we could plant a whole lot more trees. This is higher in the Cuyamacas, but all along the San Diego River, we could build a substantial forest ecosystem. I asked AI, if we wanted to start on the coast, where would we start? And the answer was there are three sensible places. The three best candidates to explore are Camp Pendleton, the northern part. Sorry, the southern part of Camp Pendleton, basically the same watersheds we were just talking about, the San Luis Rey watershed and so forth, and Camp Pendleton. A second is the vicinity of San Onofre in San Mateo Valley. There's a large military park in North Camp Pendleton, and we could plug into that park and build the forest substantial enough there. And the third best candidate is the Tijuana River Valley, uh, which should have many other benefits, perhaps in helping with the pollution at the Tijuana River and all that, and this could be tied into some of those projects. So we have multiple places in the county we could build a forest large enough. And my proposal from all of this is let's target building an old growth forest with a closed canopy in San Diego County. As an aside, within a given forest, a large diameter tree defined as 10-inch diameter or larger is an old growth tree, and they are 1% of the trees on the planet, and they store 50% of the above ground uh, carbon on the planet, the old growth trees with large diameters. So this is what I'm proposing here is that we form a task force to build an old growth forest. It probably will take a century or more, uh, ideally many more. And, it's beyond completing this project is beyond anything we can do in our lifetime, to be sure. Uh, but nonetheless, we should get it started. We don't get an old growth forest if we don't start with a young forest. So I would propose that anybody interested, we form a task force targeting the creating of a biotic pump forest in San Diego County. And we uh, do the planning and the networking and the education and all of that to make this happen. I think it's fundamental to our uh, climate endeavors and our survival with respect to water and also, of course, agriculture. So that is the conclusion for the moment, at least, of creating a biotic pump.
Excellent. Great job, Joe.
Yay.
Thank
All
you.
right.
Wonderful.
This is our time to ask some questions for Joe, and then also to if you want to, you can ask. I see Elizabeth, you've got your hand up. I'm going to call on you first. But go ahead, Elizabeth. You're on mute, Elizabeth. There you go. Is somebody's got their TV on? Could you mute that for me, please? Thank you. Go ahead, Elizabeth.
All right. It was a fantastic presentation. I learned so much, but my problem was two things I wanted to say was that I wish you could have that presentation on CNN. I want I want people to know about it. I mean, basically what it is. And the other thing is, to me, when you talk about climate change, is that we have to change our economic system in the sense that we are encouraging people to buy stuff. And this is part of the things and why we're taking down forests, et cetera, mining, in other words, more and more stuff. And we have to do both things, actually.
I agree 100%. In fact, I don't see how we begin to address overshoot. I recommend a committee on that too. I don't see how we begin to address overshoot without changing our economic system as part of it.
Right. Yeah. Thank you very much.
You're welcome, Elizabeth. Thank you.
Ron, go ahead.
Oh, so Joe, I thought this was really interesting. What role does chaparral and coastal sage scrub play? Are they are the natural thing here, right, for parts of our county?
Yes, and I think they're important. There's in 2024, the state released a report on 7 land types and regenerating and protecting them. And I don't think we shouldn't be running over our chaparral and so forth. We should encourage it and use it and and protect it. But it just is an example of the dilemmas that we have. San Diego County, some centuries ago, had large native grasses, and one of our native grasses is now reduced to, I think it's a 100-acre patch, one someplace in the county. So we have a lot of invasive plants that have been taking over for some of our native vegetation. It's another project that I think is very worthy of attention. Did I answer that well enough?
Yeah, that's helpful. Thank you.
Yeah, sure, of course. Oh, by the way, I didn't say, but in a different presentation I put together about planetary boundaries, I asked AI how much of San Diego's forest exists today compared to several centuries ago, and the answer was 22%. In our development, we have cut down, so what is it, 78% of the forests in our county. So when we talk about regeneration, yes, we have a huge deficit that we have created.
Molly, go ahead and ask your question.
Okay, well, thanks, Joe. This was kind of, I won't even say equal parts deeply depressing and a little inspiring, but at least there's some hope at the end. And I guess one of my questions is in one portion, the data showed that there is a change in the flow, basically with any small deforestation. So it makes me wonder, let's just say every schoolyard, had its own microforest.
Mhm.
Is that going to make a difference if there's big patches of asphalt in between? Like what, I guess for bang for your buck, I think probably what you finished with, the 10 square mile forest is going to be the winner. But do these little efforts add up?
Yes, they do. They do. As a Japanese arborist, I guess, his name is Miyawaki, who got Miyawaki Forest named after him. That's these mini pocket forests. The minimum size is the footprint is 6 parking spaces, and they can grow to acres. And wherever they're installed, they cool, they encourage they increase biodiversity. All kinds of little beasties find their way into these pieces of land, and uh, they are, excuse me, very popular in some countries in Japan, certainly, but in some countries in for schools. In fact, they are rampant in Netherlands. And one of the things that has happened in the Netherlands is they have school students, I think high school students, who become forest rangers, and their job is to look over and protect the pocket forests that are on public land as well as school grounds and the like. It's a wonderful book about Miyawaki forests that gosh, I can't think of the name just now, but uh, really excellent overview of their value and also how to make one. And how to produce one. And if you want to know, I'll look it up. I'll look up the book. Oh, Hannah Lewis, that's it. Hannah Lewis is the author. I've forgotten the title, but you can go to Amazon and find the book. Um, uh, Hannah is an American who is living in France and wrote this fabulous book about the benefits of these forests.
Yeah, I suppose
Hey,
biodiversity is certainly a good thing. The water cycling may not follow, but
No,
you
we
still
won't
get a
get all the
benefit.
benefits, but
Yeah,
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 you do get some cooling, and I could easily imagine students, counting the number of whatever caterpillars or something, and or ants and so forth, and looking at the biodiversity that follows from the planting.
thank
all
you.
right. Jim, why don't you take away Jim Pugh next?
It may be a silly question, but lemonade grows really vigorously and has phenomenal wildlife value. If you planted but it's not a very high plant and it doesn't have a lot of fire potential. if you planted a forest of lemonade berry, would you still get a biotic pump effect to it?
I don't know. I don't know, but I would say that forests typically have different elevation trees, right? I mean, there are big beasties and smaller ones and bushes and shrubs, and I think that interspersing them into the forest would be is certainly a
Wonderful.
wonderful thing to do. Yeah.
Well, they're just so vigorous, though. You can get a 10-inch trunk in very few years. It's just shocking
Wow. Wow.
how aggressive they are.
Well, if they're, how would I say, native enough for us, they should probably be included in the mix of trees that we choose.
Thanks,
Thank you.
Jim. Jeff, did you ever, you had your hand up?
Yeah, great presentation, Joe.
Thank you.
Fantastic. I mean, it's like makes so much sense. The science makes so much sense. You know what I think is interesting is San Diego County. I mean, as you know, I've been gone for many, many years, living somewhere else, and then I came back. But I remember the big effort about water conservation here. I mean, it seems like everybody is sort of tuned in to conserve water, whether it's, if you're brushing your teeth, turn the water off. I mean, little things, big things. It seems like if we were to have, and again, I'm coming from a communication aspect. For those of you who don't know, I'm been working in communications and advertising my career, but it seems like people are so basically primed to hear about water ideas. If we were to actually do this, it seems like it would make so much sense to people. It's like, oh yeah, this is all about water. And if we could explain it really easy, it'd be like a no-brainer. People would do it. You know what I mean? I don't think it would be a huge educational leap for people to take about, yeah, this is all about improving our water resilience.
Mhm.
And because all you got to do is say, hey man, Colorado River's drying up. Just take a look at all these like Lake Powell, Lake Mead, whatever. And they'll go like, yeah, you're right. And we've already had the conversation about the desalinization plant. It took a long time to get operational, but it's up and running. So people get it around here. So if we were to come up with these solutions, I think it would be fantastic and people would get it right
Yeah.
away.
Thank you, Jeff. I'm going to give you a homework assignment.
Okay.
Build an advertising campaign to
Campaign.
educate people and get this
Yeah.
to and help us get this to happen.
Yeah. Yeah. I've been, since you presented it at our UN Climate Action Group, I've thought of little else because it's makes so much sense. Makes so much sense. Yeah, love to work on it, and I bet you we could get media outlets, whether they're newspapers, news media, to to kick in space to to kind of populate this idea and get people to think about it.
Hey,
It's important.
hey,
It's important.
hey,
Yeah, it
Joe,
is
why don't you
totally.
put your email in the chat? So if
Oh, sure.
anybody is interested in starting this committee that he's talking about, I want you to email Joe and we can do that. Um, Ken, you're Ken Sanford. You're up next.
Hi, thank you very much.
Thank
I
you.
have a question on beneficial trees. Uh, I don't know, 50 years ago, I planted about 25 eucalyptus trees, and of course, they grow like a weed down here. And I was just wondering, are they a benefit to the system?
No.
Are they more of
You,
a burden because they just take up
you,
a lot of water?
eucalyptus trees have many deficits. When they burn, they explode. They burn easily. My friend Jim Crouch, who I mentioned, has offered to provide free oaks to the city of Vista to replace all the eucalyptus trees. They're invasive, they're not native. Uh, I'm not a tree expert on all the tree types, to be sure, but I've heard many discouraging things about eucalyptus in particular.
No, that's true. That's why I asked the question. But can you give me that reference on the free oak trees?
Sure. Yeah. Is Jim on the call? Is Jim
No,
here?
I
No.
didn't see him.
Okay. I know he registered, but anyway.
Can to Joe gives I mean is he does give away oak trees, but I would also recommend that you reach out to there are a few different organizations, believe it or not, through the county as well, and some of the cities actually give trees away too. So I would definitely look at where do you live, Ken?
I live in Escondido.
I don't know about the city of Escondido off the top of my head, but you can look at the county website and believe it or not, SDG&E gives them away too. I know they're
Oh,
kind of the
really?
devil in many ways.
I have a lot of scrub oak that are, volunteers
Mhm.
that
Oh,
Yeah.
multiplied over the
Uh,
years.
if my email is in the chat, if you send me an email, I'll send you Jim's contact info. I don't
Okay, Joe, thank
I
you.
don't know it off the top. You're welcome.
Yeah, very nice
Elizabeth.
presentation. I enjoyed it.
Thank you.
Elizabeth.
Yeah, Joe, is this an article? Because I would like to send what you have said or your presentation. I'm one of the editors of Green Social Thought and
Uh-huh.
would like to send it to everybody on our list. And so is it a written piece that you've done that?
No, I haven't, but you're welcome to take the recording and share it with everyone.
Yeah, well, we don't do recordings
Oh,
on
I see.
so
But Joe, you could share the PowerPoint with Elizabeth.
Oh yeah, you can anybody who wants, I'm happy to share the PowerPoints and the like and
Here's
okay.
yeah.
here's what we'll do tomorrow. We'll do the next couple of days. We'll make sure that I get the slide deck from Joe and we'll send it out to everybody who participated.
Okay, good. Thank you very much.
You're
Great.
You're
welcome.
welcome. We're about ready to wrap things up here.
Pat has a question.
Okay, go ahead. I'm sorry. Missed it.
Um, if people quit using any chemicals on their property, no matter how big or small, and it's doable, mankind's been doing it for millennia. The chemical industry came from the war industry just shortly ago. We don't need those chemicals. And if we save the cuttings, the grass, the leaves from our yard instead of giving them to the city to mix with the stuff that has chemicals, we can put that into our compost with the scraps from our organic food that we put in our kitchen. So again, we're not putting chemicals in. We've been doing that for only 30 years, and we have trees that have the diameter that Joe was talking about.
Nice.
Uh, if you do enough composting, if you work with nature, nature helps you, and we sure found that. We've made mistakes along the way and we learn along the way, but anyone who is willing to do that kind of thing, I would happily give a tour of our 1/20th of an acre food forest that provides rain. It's a little rainforest. We have more than one place that we capture rain. I have a friend who puts a bucket in her sink when she washes her produce, and that goes outside to water her garden too. You would be surprised what you can do. My phone number is 858-455-1033. And my name is Pat, like a pat on your back, and Holland, like the country with windmills. Further, I would suggest, a place that people don't have to pay to get into, to put this presentation, like, Netflix you have to pay to get into, but
YouTube.
YouTube, exactly what I was going to suggest half an hour ago, because everyone uses YouTube to learn. And there are other venues that I'm not thinking of at the moment that are free, because you don't just want people rich enough to have cable to know this. You want everyone to know it. Thank you.
Yeah, if someone knows how to do that or where to place it, by all means, let's do.
Here, I'll put my phone number in the chat.
Thank,
I'm
thank, thank you, Pat.
Thank
Mhm.
you, Pat. All right, everybody. I think this is a highly successful event. I do want to, if climate change is something you're really interested in, one of the things that Joe mentioned in the very beginning is going to be a topic of our next Sierra Talk. Our next Sierra Talk is actually going to be January 29th from 6 to 8. Professor Abigail Burke will be joining us, and it's all going to be about the inroads. And Inroads is an online simulator that provides policymakers, educators, businesses, the media, and the public with the ability to test and explore cross-sector climate solutions. So you get to actually find out what you're doing in the simulator. So it's super exciting. We're the first organization in the San Diego County that'll be demonstrating this, and it'll be on January 29th from 6 to 8. I also want you to know this is our third Sierra Talk. These have been really successful, and we are really wanting to keep these going. So as the end of the year is coming, we really want you guys to if you've enjoyed these things, please reach out to us. If you have contacts that want to do an inroads model, that want to do a Sierra Talk, please have them reach out to me. We would love to do that, and we're really wanting to get all diverse people who can give talks about things that are important to all the Sierrans of San Diego and Imperial County as well, because that's where our chapter is from. So so thank you very much. I hope everyone has a fantastic holiday season. Whatever you are celebrating, enjoy it. Spend time with loved ones, spend times with friends. But last but not least, let's give it up for Joe.
Oh, well, thank you, Mark.
Good
Happy
job,
holidays to everybody.
All right. Everybody have a great night. Enjoy it. Take care.
Bye-bye.
Joe, I hope
Hello.
you guys sometime and visit with your wife. Did you hear? No? Joe? Shoot. Put me last so no one got to see the chat.